Step 1. Acquiring data. The first step in the data science process is to acquire the data. You need to obtain the source material before analyzing or acting on it. The first step in acquiring data is to determine what data is available. Leave no stone unturned when it comes to finding the right data sources. You want to identify suitable data related to your problem and make use of all data that is relevant to your problem for analysis. Leaving out even a small amount of important data can lead to incorrect conclusions. Data comes from many places, local and remote, in many varieties, structured and unstructured, and with different velocities. There are many techniques and technologies to access these different types of data. Let's discuss a few examples. A lot of data exists in conventional relational databases, like structured big data from organizations. The tool of choice to access data from databases is Structured Query Language, or SQL, which is supported by all relational database management systems. Additionally, most database systems come with a graphical application environment that allows you to query and explore the datasets in the database. Data can also exist in files, such as text files and Excel spreadsheets. Scripting languages are generally used to get data from files. A scripting language is a high-level programming language that can be either general purpose or specialized for specific functions. Common scripting languages with support for processing files are JavaScript, Python, PHP, Perl, R, and MATLAB, among many others. An increasingly popular way to get data is from websites. Web pages are written using a set of standards approved by World Wide Web Consortium, or shortly, W3C. This includes a variety of formats and services. One common format is the Extensible Markup Language, or XML, which uses markup symbols or tabs to describe the contents on a web page. Many websites also host web services which produce programmatic access to their data. There are several types of web services. The most popular is REST because it's so easy to use. REST stands for Representational State Transfer, and it is an approach to implementing web services with performance, scalability, and maintainability in mind. WebSocket services are also becoming more popular since they allow real-time notifications from websites. NoSQL storage systems are increasingly used to manage a variety of data types in big data. These data stores are databases that do not represent data in a table format with columns and rows as with conventional relational databases. Examples of these data stores include Cassandra, MongoDB, and HBase. NoSQL data stores provide APIs to allow users to access data. These APIs can be used directly or in an application that needs to access the data. Additionally, most NoSQL systems provide data access via a web service interface, such as REST. Now, let's discuss our Wildfire case study as a real project that acquires data using several different mechanisms. The Wildfire project stores sensor data from weather stations in a relational database. We use SQL to retrieve this data from the database to create models to identify weather patterns associated with Santa Ana conditions. To determine whether a particular weather station is currently experiencing Santa Ana conditions, we access real-time data using a WebSocket service. Once we start listening to this service, we receive weather station measurements as they occur. This data is then processed and compared to patterns found by our models to determine if a weather station is experiencing Santa Ana conditions. At the same time, tweets are retrieved using hashtags related to any fire that is occurring in the region. The tweet messages are retrieved using the Twitter REST service. The idea is to determine the sentiment of these tweets to see if people are expressing fear, anger, or are simply nonchalant about the nearby fire. The combination of sensor data and tweet sentiments helps to give us a sense of the urgency of the fire situation. As a summary, big data comes from many places. Finding and evaluating data useful to your big data analytics is important before you start acquiring data. Depending on the source and structure of data, there are alternative ways to access it.